Welcome to Star Chat, the podcast that explores the wonders of the universe and brings you the latest news from the world of astronomy. I'm your host, Carl, and I'm excited to share with you today's top story. Imagine a vast bubble of gas and dust surrounding a dying star, stretching out to half the width of our entire solar system. This is not just a poetic description, but a real phenomenon that has left astronomers baffled. The star in question is called DFK 52, a red supergiant located in a distant corner of the universe. As we gaze up at the night sky, it's easy to forget that stars like DFK 52 are actually massive balls of hot, glowing gas, nearing the end of their life cycle. They've exhausted most of their fuel, and are now expanding rapidly, expelling enormous amounts of gas and dust into space. This creates a bubble around the star, known as the circumstellar medium, which can influence how the star ultimately explodes in a supernova. But here's the fascinating part. DFK 52's bubble is unlike anything we've seen before. It's not just large, it's enormous, with a complexity that has astronomers scratching their heads. The team of researchers led by Mark Siebert at Chalmers University of Technology in Sweden used the Atacama Large Millimeter Array, or ALMA, to observe the star and its surroundings. What they found was a structure that defies explanation, with intricate streams of bubbles moving throughout the sphere, and a ring-like bar expanding at nearly 30 kilometers per second. The question on everyone's mind is, how did this happen? How could a single star produce such an enormous amount of material in such a short time? The answer, unfortunately, remains a mystery. Siebert and his team have proposed several theories, including the possibility that the star was once much brighter and has since dimmed, or that another star may have been circling close to DFK 52, slinging off material into space. But none of these explanations seem quite right. As we ponder the enigma of DFK 52's vast bubble, we're reminded of the awe-inspiring complexity of the universe. There's still so much we don't understand, and it's stories like this that inspire us to keep exploring, to keep seeking answers to the biggest questions of all. We'll be right back with more fascinating space news on Star Chat. Welcome back to Star Chat. We're diving into the fascinating world of space exploration and the ongoing quest to discover life beyond Earth. Today, we're talking about the latest developments in the search for extraterrestrial life, and I have to say, it's getting more exciting by the day. Scientists are working tirelessly to develop new instruments and technologies that can help us analyze the chemical composition of exoplanet atmospheres. This is a crucial step in determining whether these planets might be capable of supporting life. And let me tell you, the prospects are looking promising. We're not just talking about simple life forms like bacteria or microbes. We're talking about the possibility of complex life existing on other worlds. The discovery of exoplanets with conditions similar to those of Earth has sparked a new wave of interest in the search for life beyond our planet. One of the most significant challenges in this field is reducing humanity's specialness. As Dr. Robert Massey, Deputy Executive Director of the Royal Astronomical Society, puts it, centuries ago we believed we were at the center of the universe, and with each discovery in astronomy, we found ourselves more displaced from that point. But what if we do find life on other worlds? What would that mean for us? According to Professor Nikku Madhusudan, the discovery of alien life would be a huge transformational change in the way we look at ourselves in the cosmic scene. It would fundamentally change the human psyche and make us realize that we're all part of something much bigger than ourselves. And it's not just about the science, it's about the potential impact on our society and our daily lives. The discovery of extraterrestrial life could bring people together, transcending linguistic, political, and geographical barriers. As Professor Madhusudan so eloquently puts it, it will be another step in our evolution. The search for life beyond Earth is an ongoing journey, and we're getting closer to finding answers. With the latest advancements in technology and the dedication of scientists around the world, it's only a matter of time before we make a groundbreaking discovery. Stay tuned for our final story of the day, right here on Star Chat. Welcome back to Star Chat. As we conclude our journey through the cosmos today, I'd like to take you to a fascinating exoplanet that has been making headlines in the astronomical community. You might recall our previous discussions about K2-18b, a super-Earth located about 111 light-years from us, which had shown promising signs of hosting life due to the presence of water vapor, and potentially even a biosignature in the form of dimethyl sulfide in its atmosphere. However, as with all scientific inquiries, the story of K2-18b is one of ongoing exploration and refinement. Recent research published by Renyu Hu at the California Institute of Technology and his colleagues, including Niku Madhusudan, brings new insights into the mystery of whether K2-18b's atmosphere truly harbors DMS, a compound that could be indicative of biological activity. Using the near-infrared camera on the James Webb Space Telescope, the team analyzed light passing through K2-18b's atmosphere. While their findings did not provide conclusive evidence for the existence of DMS, they did suggest that if such a molecule is present, it could be masquerading as part of other chemical signatures, making detection challenging. One crucial aspect of this study is the realization that certain hydrogen-rich atmospheres on planets like K2-18b can produce DMS without any biological intervention. This discovery narrows down our understanding of which molecules can serve as exclusive biosignatures in exoplanet atmospheres and suggests that DMS, while intriguing, may not be as definitive a marker for life as once thought. Despite the lack of clear evidence for DMS, the research did confirm something quite remarkable about K2-18b. Its atmosphere is rich in water, along with methane and carbon dioxide. This points to a planet with significant potential for liquid water, either in the form of oceans, atmospheric moisture, or water locked within its interior. As we reflect on these findings, it's essential to recognize that the search for life beyond Earth is a complex, iterative process. Each new observation, each refinement of our understanding, brings us closer to unraveling the mysteries of the cosmos, but also reminds us of how much remains to be discovered. The story of K2-18b serves as a poignant reminder of the scientific method's power and the importance of ongoing exploration. As we continue our quest to understand the universe and our place within it, we're constantly reminded that the truth is out there, waiting for us to uncover it with persistence, curiosity, and the latest advancements in technology. That's all for today's Star Chat. Remember to like, share, and subscribe. And until next time, remember to keep looking up at the stars.